Packaging preservation techniques, chemistry insights. Packaging preservation techniques, chemistry insights. In our modern world, packaging plays a crucial role in preserving the quality and safety of various products, ranging from food and pharmaceuticals to electronics and consumer goods. In this article, we delve into the realm of packaging preservation techniques and explore the chemistry insights that drive these innovations. The chemistry behind packaging preservation. Effective packaging preservation techniques rely on a deep understanding of the chemical processes that can degrade products over time. Several factors contribute to the deterioration of packaged products, including exposure to light, oxygen, moisture, temperature fluctuations, and interactions with other substances. By utilizing chemistry insights, researchers and engineers can develop packaging solutions that counteract these adverse effects. Barrier materials and oxygen scavengers. One of the primary concerns in preserving packaged products is preventing the ingress of oxygen, which can trigger oxidation reactions that lead to spoilage, flavor changes, and reduced shelf life. To address this issue, packaging scientists employ barrier materials that minimize the permeation of oxygen through the packaging. These materials are often polymers with dense molecular structures that create an effective barrier against gas diffusion. However, even with advanced barrier materials, some oxygen molecules may still find their way into the package. To combat this, oxygen scavengers are employed. These scavengers are materials that react with oxygen, effectively removing it from the package's atmosphere and preventing its detrimental effects. Iron-based oxygen scavengers, for instance, consist of iron powder and a catalyst enclosed in a sachet within the package. When oxygen enters the package, it reacts with the iron powder, forming iron oxide and effectively eliminating the oxygen. Moisture control and desiccants. Moisture is another critical factor that can contribute to product degradation. Excessive moisture can lead to mold growth, bacterial proliferation, and chemical reactions that compromise product quality. Packaging preservation techniques often involve incorporating desiccants, which are materials that have a high affinity for water and can effectively absorb moisture from the package's environment. Silica gel is a common desiccant used in packaging. Composed of silicon dioxide, silica gel can absorb water vapor through its porous structure. When placed in the packaging, it helps maintain a dry environment, thus preventing the growth of microorganisms and the occurrence of moisture-induced chemical reactions. Light protection and UV absorbers. Light, especially ultraviolet, UV, light, can initiate photochemical reactions that degrade products and alter their chemical composition. This is particularly relevant in the packaging of sensitive substances, as pharmaceuticals and certain food products. Packaging preservation techniques often involve incorporating UV absorbers or blockers into the packaging material. UV absorbers are compounds that can absorb UV radiation and dissipate it as heat, preventing it from interacting with the packaged product. These absorbers are typically incorporated into the polymer matrix of the packaging material itself. By selecting the appropriate UV absorbers, packaging engineers can tailor the packaging to provide optimal protection against light-induced degradation. Antioxidant packaging additives. In many cases, product degradation is caused by oxidative reactions initiated by free radicals. Free radicals are highly reactive molecules that can damage the chemical structure of products, leading to color changes, off flavors, and reduced shelf life. To counteract this, packaging scientists can incorporate antioxidant additives into the packaging material. Antioxidants work by neutralizing free radicals and preventing further oxidative reactions. For instance, vitamin E, a well-known antioxidant, can be incorporated into packaging materials to protect products from oxidative degradation. Active and intelligent packaging. In recent years, packaging preservation techniques have evolved beyond passive strategies and ventured into the realm of active and intelligent packaging. Active packaging involves incorporating materials that interact with a packaged product to extend its shelf life. For instance, antimicrobial agents can be integrated into packaging materials to inhibit the growth of bacteria and other microorganisms, thus prolonging the product's freshness. Intelligent packaging, on the other hand, incorporates sensors and indicators that provide real-time information about the condition of the packaged product. For example, temperature-sensitive labels can change color if the product has been exposed to temperature conditions that might compromise its quality. Such packaging innovations not only rely on chemistry insights but also incorporate technological advancements to create more responsive and effective preservation solutions. Sustainability considerations. While packaging preservation techniques are essential for maintaining product quality, the environmental impact of packaging cannot be ignored. Many conventional packaging materials are non-biodegradable and contribute to pollution and waste. As a result, researchers are exploring sustainable packaging alternatives that balance preservation needs with environmental responsibility. Biodegradable and compostable packaging materials, often derived from renewable resources such as cornstarch or sugarcane, are gaining traction. These materials can break down naturally, reducing their impact on the environment. Additionally, research is being conducted to develop packaging materials that are not only barrier efficient but also easily recyclable. Conclusion. Packaging preservation techniques are a dynamic field where chemistry insights drive innovation. Future directions in packaging preservation. As we look to the future, several exciting developments are on the horizon in the realm of packaging preservation. These advancements are poised to revolutionize how we approach packaging and extend the shelf life of products while minimizing their environmental footprint. Nanotechnology in packaging. Nanotechnology, which involves manipulating materials at the nanoscale level, holds great promise for enhancing packaging preservation. Nanocomposites, which consist of a polymer matrix embedded with nanoparticles, can create packaging materials with unprecedented functionalities. For instance, silver nanoparticles can be added to packaging to provide antimicrobial properties, reducing the growth of harmful microorganisms and extending the shelf life of food products.